Greetings, Gen Chem students. This is part B of the calorimetry online lab that we're in the process of doing. And this part deals with measuring the heat energy associated with the formation of a solution, specifically the formation of solutions of two different ionic compounds. And those two ionic compounds are ammonium chloride and calcium chloride. Here we see the reactions of those when you put them into water. Ammonium chloride added to water, that's what the arrow with the H2O means. We're putting it into water. And you know what ionic compounds do when added to water? They dissociate 100% into their constituent ions. So this would be the ammonium chloride solution formation reaction. Notice we have little aqueous subscripts there. We start with a solid. And this would be the one for calcium chloride. Calcium chloride, solid, an ionic compound, put it into water, dissociates into aqueous calcium plus 2 ions and 2 chloride aqueous ions. And what we want to do is to experimentally measure the heat energy associated with these solution processes. Now you should have your protocol in front of you while you do this, and step 1 would be to add 50 mL of water to your calorimeter, and then add 5 grams of the salt, the ionic compound, whichever one you happen to be working with at the moment, and then immediately put on the top of the calorimeter and stir and record the final temperature. I've taken the initial temperature of the water, the 50 mils, which is 50 grams, same as 50 grams. The initial temperature was 20.5 degrees C. So let's set up the experiment for calcium chloride. Let's do this one. And we come over here and we measure out 50 mils of water. This is water, add it to the calorimeter. And then we take 5 grams of our calcium chloride. I measured that out earlier. And I'm going to add that to the calorimeter. And as soon as I add it, boom, I'm going to put the top on and then start stirring. And what's the temperature doing here? And the temperature is rising. Oops. Just better keep it low so you can see what's going on here. So let that continue to dissolve, and as it continues to dissolve, the temperature is going to continue to change as a result of the heat of the reaction that's involved. So we've done part 1. We've added the 50 mils of water to the calorimeter. We had taken the temperature of that, the initial temperature, TI. We added the 5 grams of the calcium chloride. We're stirring, and now we're waiting for the temperature to reach its final state and stop rising. And I'm getting 22.5. So that would be our final temperature, T final. Let me get a blue pen. T final is 22.5 degrees C, and we started at 20.5 degrees C, so our delta T, which is T final minus T initial, is going to be 22.5 minus 20.5, so our delta T is going to be equal to 2.0 degrees C. And notice it's a positive change. The temperature went up. So now we take that data, and our data is what? 50 mils of water, which is the same as 50 grams, 5 grams of the salt, the calcium chloride, and a temperature change of 22.5 minus 20.5 of 2.0. And we plug them into our working equation. And this is equation 5 from our online introduction video. The heat of the formation of a solution of calcium chloride is equal to negative the heat of the water in the calorimeter. Heat of the water is given by the mass of the water, which is 50 grams, because each mil of water is 1 gram per mil. Specific heat capacity, which is 4.18 joules per gram per degree C, and our delta T. And that would give you your heat of reaction. And notice we have a negative. Don't drop that negative. And that negative times a positive temperature change is going to give us a negative heat of reaction. It'll be an exothermic reaction, or it is an exothermic reaction. So now what you do is you go to the Show Me online video for the Part B calorimetry calorimetry. And you'll see some further calculations that you need to do for your lab report with this. And it turns out that we've already done the ammonium chloride, and the temperature change for the ammonium chloride was negative. Negative 4.5 degrees C. The temperature went down. And you're going to see when you plug in that negative temperature times this negative here, you're going to get a positive heat. Not a negative heat like we got with the calcium chloride, but a positive heat, indicating that this is an endothermic process. And that's the story.